Here's problem 2920. A deuteron is accelerated from rest through a 10 kilovolt potential difference and then moves perpendicularly to a uniform magnetic field with a magnetic field equal to 1.6 Tesla. What is the radius of the resulting circular path? Well, the potential energy difference it goes through is equal to the charge times the change in potential, and that's going to be equal to 1.6 times 10 to the minus 19 coulombs times 10,000 volts, which is going to give us a change of energy of 1.6 times 10 to the minus 15 joules. All that change in potential energy will go into kinetic energy. So in other words, our change in kinetic energy is going to equal this change in potential energy, at least in magnitude. So that's going to equal 1.6 times 10 to the minus 15 joules. Well, the change in kinetic energy is the final kinetic energy minus the initial, which is 0. So this is going to equal 1/2 mass times our final velocity squared. So our final velocity is going to equal 2 times the change in kinetic energy divided by the mass square root, which is going to be, if I can get this right, 2 times 1.6 times 10 minus 15 joules over the mass 3.3, approximately twice the mass of a proton, times 10 to the minus 27 all this square root, and that's equal to 9.85 times 10 to the 5 meters per second. Sounds good. Well, we can use that velocity for our radius equation. The radius should equal the momentum, mass times velocity, over the charge times the magnetic field. And that's going to be equal to the mass, 3.3 times 10 to the minus 27, if I can get this to right, times the velocity, 9.85 times 10 to the 5, which we just found, over the charge, same charge as a proton, 1.6 times 10 to the minus 19, times the magnetic field, which is 1.6. And this is equal to 0.0127 meters. So as the radius it will go through, 0.0127 meters, we could say approximately 13 millimeters. Algebraically, we could have left the energy in terms of voltage and mass and charge, and then substitute that into this radius equation. But this is a straightforward way of looking at this problem, and that's why I preferred this.